Today we're going to be talking about section 5.1, which is on operations with polynomials. So there's a couple properties that we need to know with exponents that is going to help us with solving polynomial problems. The first one is product of powers. When you are multiplying two numbers with, notice, the same base of x, okay, or any number, when we multiply them, we just add the exponent. So an example would be like 3 to the second times 3 to the fourth is 3 to the 2 plus 4, which is 3 to the 6. Quotients of powers, meaning division, what we do, if they have the same base, notice this one has x and x, what I'm going to do is I'm going to subtract the top exponent from the bottom. So an example would be like this one. B to the 6 divided by b to the 4th would be b to the 6 minus 4, which is b to the 2nd. Anytime we have a negative exponent, we can rewrite this. Okay, so we have x to the negative a power. What we can do is rewrite it as a fraction, and it's going to be 1 over x to the a power. So for example, 3 to the negative 5 is the same as 1 over 3 to the 5th power. Power of a power, this one's a little bit different. This one's going to get tricky when we start multiplying, but power to a power is this, x to the a power to the b power, and you multiply them together. So like d to the 2nd to the 4th is going to be d to the 2 times 4, which is d to the 8th. Product of a power, okay, so when we have like x and y together to the a power, it's the same as x to the a times y to the a. Okay? Power of a quotient, okay, so if you have x and y right here, and you have to the a power, it's the same as x to the a over y to the a. Same with a negative exponent, which actually can flip it. And then finally the last one rule in math that just kind of is always known as anything to the 0 power is 1. So 7 to the 0 power would mean the example of 1. So we can use all of this information and all of these properties of exponents to solve polynomial problems. So let's look at what we got to do to simplify. Okay, so we need to make sure anytime we're simplifying, there's no power to a power. Okay, each base is only there once. All fractions are in the simplest form, and then we don't have any negative exponents. So we'll come back to this and make sure that it's simplified all the time. So example 1, simplify each expression assuming that no variable equals 0. So when I'm looking at letter A, what I'm going to do first is I'm going to look at the things that I know I can do without having any properties. So that's going to be 2 times 3, and then there's a little ghosty 1 coefficient in there as well. So that would be 2 times 3 times 1 is going to be 6. Now, our property of multiplying all of them with the same base a was we were going to add the exponents. So a to the negative 2 times a to the 3rd would be a to the negative 2 plus 3. That's going to be a to the 1. And you don't have to write the 1. I did this time just to look at it. Then the next one. I look for any other b's. I only see that one, so that's going to be b to the 2nd. And then the last one, c, is to the negative 2. Now I'm not done simplifying yet, and the reason that is because one of my rules when I was simplifying monomials was that I never had a negative exponent. So anytime you have a negative exponent, that's actually going to go to the bottom. Okay? So I'm going to rewrite this as 6a. Now I'm not going to put the 1 in it, but a, b to the 2nd, all over c to the 2nd. So there we are. This is in simplest form. Okay, I don't have any power to a power. I don't have any bases, a, b, c, whatever, showing up more than once, and I don't have any negative exponents. Let's look at letter B here. Letter B, q to the 2nd over r to the 4th over q to the 7th times r to the 3rd. So first I'm going to look at my q's. Okay, well, I have 2 on top, 7 on bottom. 2 minus 7 is q to the negative 5 power. Then I look at r. r to the 4th over r to the 3rd. r to the 4 minus 3 is r to the 1. So this is not simplified yet because I have that negative q in there. So I'm going to keep r on top and then q to the 5th on bottom. That is my simplified answer. letter C. So if I'm looking at letter C, the first thing I see is that I have this whole quotient to the power of 3. So I'm going to go through and I'm going to give that power of 3 to everything within my parentheses. So I get negative 2 to the third power. I get a to the 4 times 3, which is 12 power, over b to the 2 times 3, which is b to the 6th power. Now the only thing I need to do to finish simplifying this is I have this negative 2 to the third power. And so negative 2 times negative 2 is positive 4, times a negative 2 is negative 8, a to the 12th, b to the 6th. And again, you'll see I don't have any base show up more than once. I have it in my simplest form of a fraction, and no power to a power. Here's a couple guided practice problems that you can try as well. So let's look at letter B. Okay, so the first thing I'm going to do to simplify is 15 over negative 3. Well, 15 divided by negative 3 is negative 5. Then I have c to the 5 over c to the 2. 5 minus 2 is c to the third. And then I have d to the third over d to the 7th. 3 minus 7 is d to the negative 4. Or I can just write d to the 4th on the bottom. There's my simplified form. The degree of a polynomial is the degree of the monomial with the greatest number. Right? So, determine whether each expression is a polynomial. If it's a polynomial, state the degree of the polynomial. Okay? So a couple things that we need to know about degrees of polynomials. Important information about polynomials is A, everything has to be a monomial. It has to be a power that's a whole number and not negative. So if I look at the first one, letter A, okay, is this a polynomial? Well, I have x to the 4th and y to the 3rd and x to the 5th. So yes, this right here is an example of a polynomial. Okay, so I'm going to write polynomial. Alright, and now I'm going to find the degree. And the degree is always the biggest, or the biggest total number in their power. So if you look right here, I have 4 and 3. So 4 plus 3 is a total of 7. And this is 5. So which one of these numbers is the greatest? It's going to be 7. So this is going to be degree 7. Now in letter B, I look at the powers. I see the square root of x plus 4. Now the first thing that kind of pops out of me is this, the square root of x. The reason it pops out is because it's not a whole number that has a degree. So this is not a polynomial. Okay. Now letter C, x to the negative 3 power plus 2x to the negative 2 power plus 6. Now I see that I have negative exponents. And anytime I see negative exponents, I'd have to rewrite them as like 1 over x to the 3rd. And this would be 2 over x to the 2nd. And anytime I'm dividing by an x or a number or a variable or something like that, it ends up not being a nice degree. So this also is not a polynomial. So the only polynomial that we had here in A, B, and C was example A, because all of my powers were whole numbers and they were positive. So if I look at these guided practice problems, you can try them now. Now the question for 2A was, why is this not a polynomial? And the reason it's not is because I'm dividing by y. And so anytime you're dividing by some sort of variable, like I said in example C, it's not a polynomial. So the reason it isn't is because we have y as a divisor. Now, if you didn't say that exactly, that's totally fine. But that's essentially the reason why, because y is a divisor, not a whole number polynomial. Alright, so now we're asked to simplify polynomials. And this goes back to when we started with pre-algebra. You're finding your common, your like terms, your common terms, and you're going to simplify them. So if I look at the first one, I have 4x squared minus 2x squared. So 4x squared minus 2x squared, I have 2x squared left over. Next, I have minus 5x minus 3x. So negative 5, and I'm going down 3 more, it's going to be minus 8x. Lastly, I have 6 minus a negative 1. Well, minus a negative is adding. So 6 plus 1 would be plus 7. So here is my simplified term polynomial. Alright, letter B. 6x squared plus a negative 4x squared is going to be 2x squared. Then I have minus 7x plus 9x, which would be plus 2x. And then finally I have plus 8 plus a negative 5 would be plus 3. So I simplified these terms. Here's a couple guided practice problems that you were asked to try. We're asked to try letter B. 3x squared plus no other x squared is just going to be 3x squared. Then I have, I don't have an x term here, so I look over here and I have minus an x term. Notice it's because it's plus a minus. Now, if it was minus a minus, that would be a positive x, but it's not. And finally, the last one, negative 6 plus 1 would be negative 5. So there is my simplified polynomial. Now, we can also use the distributive property. We talked about the distributive property back when we started talking about simplifying polynomials. All I'm doing is I'm distributing that 3x to all the numbers within the parentheses. So 3x times 2x squared is going to be 3 times 2 is 6. And x times x to the second would be x to the 1 plus 2 is 3 power. Then I have 3x times a negative 4x. Well, 3 times negative 4 is negative 12. And x times x, 1 plus 1 is x to the second. And finally, the last one, 3x times a positive 6 would be positive 3 times 6 is 18, and the x just takes along. So I can again use my distributive property to simplify. Here's a couple guided practice problems that you can try. Now in letter A, the same thing. I'm going to take 4/3 x squared times 6x. Well, 4/3 times 6 is going to be an 8, and x to the second times x to the second is x to the 4th, plus 4/3 times 9x. That's going to be 12, and then x to the second times x is x to the third. And finally, the last one, 4/3 times a negative 12 would be negative 16, and then the x squared just hangs along. So here's my simplified version of my guided practice problem for it. Alright, and so we can actually write real-world problems with this. It says the U.S. Department of Transportation limits the time a truck driver can work between periods of rest for 10 hours. For the first part of the shift, Tom drives at a speed of 60 miles per hour, and for the second part, he drives at a speed of 70 miles per hour. Write a polynomial to represent the distance driven. So we actually have it written here, which is real nice. Okay, so 60 miles per hour for some of the time, so we can do 60 times x. And then the next part says 70 miles an hour for the rest. So that would be plus 70 times 10 minus x. And so what we're asked to do then is 60 times x is just 60x. 70 times 10, 70 times a negative x would be negative 70x plus 700. And so what we can do is we can just simplify. So I'm going to actually move the 700 in front, so it'll be 700, and then minus 60 minus 10x would be minus 10x. So this is the amount of time he spends, or distance driven. So 700 miles minus 10 times x. The last example I want to look at is example 6. And what we're going to do is we're going to multiply these polynomials. Much like the FOIL method, I'm going to take n squared, I'm going to multiply it by n. That's n to the third. Then I'm going to take n squared, and I'm going to multiply it by a positive 2. That'll be plus 2n squared. Then I'm going to take 4n, multiply it by n, so that'll be 4n squared. Then I'll take 4n and multiply it by a positive 2. That'll be plus 8n. Lastly, I take negative 6 times n, which is negative 6n. And negative 6 times a positive 2 would be negative 12. Now I simplify, and I get n to the third plus 6n squared plus 2n minus 12.